Welcome back to Security for Legal SaaS. I'm Alice.
And I'm Dan. Episode 7, Input Validation and Sanitization. Alice, last episode we covered how web apps communicate. Today we're at the front gate. Data comes in from the outside world. How do we decide what gets through?
This is the single most impactful security practice you can implement. Every injection attack. SQL injection, where attackers sneak database commands into your input fields. Cross-site scripting, where they inject malicious scripts into web pages. Command injection, where they trick your server into running system commands. Starts with invalid input that your application processed without checking. Input validation is asking, does this data look like what I expected?
So give me the fundamental decision. How do you define valid?
Two approaches. An allow list, sometimes called a whitelist, says only these specific patterns are permitted. A deny list, or blacklist, says block these known bad patterns, allow everything else. A WASP is unequivocal, use allow lists. Always.
Right. Why is the deny list approach so dangerous?
Because the set of malicious inputs is infinite. You block script tags, the attacker uses event handlers. You block angle brackets, they use Unicode equivalents. You block single quotes. They use double encoding. Every WAF bypass technique, WAF being the web application firewall from episode 4, in existence exploits deny list apps. But an allow list that says a single port case citation must match the pattern bracket, 4 digits, bracket, space, 2 to 6 uppercase letters, space 1 to 5 digits. Defined using a regex, a regular expression which is a pattern matching formula. That rejects everything that isn't a valid citation, including every possible attack payload.
That's elegant for structured data. But what about free text fields? A lawyer's case notes, for instance.
Free text is harder, which is why validation alone isn't sufficient. For free text, you validate what you can. Character encoding must be UTF-8, which is the standard way computers represent text, including international characters. Length must be under your maximum, no null bytes. Then you rely on output encoding, converting special characters into safe representations before displaying them, and parameterized queries, as we'll cover in detail next episode, to handle the content safely. Validation is your first layer, not your only layer.
Where does validation need to happen? I've seen debates about client-side versus server-side.
There's no debate. Server-side is mandatory. Client-side is optional UX polish. An attacker can disable JavaScript, modify the DOM, the document object model, the browser's internal representation of a web page that JavaScript can read and modify, or bypass the browser entirely by calling your API. Application Programming Interface, the programmatic endpoints your server exposes, directly with curl. If your only validation is in the browser, you have no validation.
Right. So why do client-side at all?
User experience. Immediate feedback when a lawyer types an invalid case number. Fewer wasted round trips to the server. But it's never security. It's convenience. The server must independently validate everything, regardless of what the client claims to have checked.
Legal SaaS has some distinctive input types: case citations, court codes, statute references. How do you handle those?
Domain-specific AL lists. A Singapore case citation follows the pattern bracket year bracket, court code, case number. You can define that as a regex, a regular expression pattern, and reject anything that doesn't match. Court identifiers, SGCA, SGHC, UKSC, EWCA, are a finite set. That's a strict allow list and enum. Statute references have known patterns per jurisdiction. The key insight is that legal data is often highly structured, which makes it easier to validate strictly than general web input.
Yeah. What about the tooling layer? I hear a lot about Zod, Pydantic, schema validators. Right.
These are runtime schema validators, libraries that automatically check whether incoming data matches your expected structure. that sit between your API endpoint and your business logic. Zod for TypeScript and Pydantic for Python are the two most popular ones. You define a schema. This field is a string matching this regex. That field is an enum of these values. This date must be in the past, and the library validates incoming data against it automatically. If validation fails, the request is rejected before your business logic ever sees it.
And OMs add another layer.
Yes, your ORM, Object Relational Mapper, the library that generates database queries from your code. Its schema defines type constraints, length limits, foreign key relationships, and enum restrictions at the database layer. Between Zod at the API boundary and Prisma at the database boundary, malformed data has to pass through two independently defined validation layers. That's defense in depth.
One thing I want to clarify. Validation versus sanitization. They're different?
Critically different. Validation checks whether input conforms to expectations and rejects it if it doesn't. Sanitization modifies input to make it safe, stripping dangerous characters and coding special characters. The safer pattern is validate first, reject if invalid. Only sanitize when you have a legitimate business reason to accept input that contains characters meaningful in another context.
Why is sanitization riskier than rejection?
3 reasons. First, your sanitizer might miss an encoding it doesn't handle. Second, modified input might have unintended meaning. You strip characters from a case citation and now it references the wrong case. Third, silent sanitization masks attacks. If an input field is receiving SQL injection attempts, you want to know about it. Logging a validation rejection gives you visibility. Silently cleaning the input hides the attack.
Right. That connects to monitoring. Right. Validation failures are security signals.
Absolutely. A sudden spike in validation failures on your case search endpoint could mean an attacker is probing for injection vulnerabilities, or a compromised account is running automated scripts. Log every validation failure. The endpoint, the rejected input, sanitized for the log, the source IP, the authenticated user. Feed that into your CM, your security information and event management system, the centralized dashboard that aggregates and correlates security alerts across your entire infrastructure. OWASP recommends this explicitly in their logging cheat sheet.
What about the ordering problem? I've seen validators that check input before it's decoded.
Yeah, classic mistake. If you validate before URL decoding, the process of converting encoded characters like %3c back to their original form, an attacker sends %3c script %3e. Your validator sees %signs, not angle brackets, and passes it through. Then your application decodes it, and now you have a script tag in your data. The rule is canonicalize first. Decode, normalize Unicode to NFC, which is a standard form that ensures the same character is always represented the same way, resolve any encoding layers, then validate. Always validate the final form of the data, not an intermediate representation.
Any other common mistakes in the legal tech context?
Missing length limits is huge. Without them, an attacker can submit a 50 megabyte string as a case note and crash your parser or exhaust server memory. Type coercion in JavaScript, where the string 0 equals false, leads to bypass conditions and Boolean checks. And null byte injection. Inserting a 0 byte but some C-based libraries interpret as a string terminator, causing truncation in file paths or database queries. Reject null bytes unconditionally in any web input.
So the summary: allow list over deny list. Server side is mandatory. Validate before your business logic sees data. Log failures as security signals. And canonicalize before you validate.
And remember, validation stops the obviously wrong. The next episodes cover what happens when subtly wrong data gets through. Parameterized queries, output encoding, content security policies, rules that tell the browser which scripts are allowed to run. Those are your deeper defenses.
Next episode: SQL injection and ORM safety. What happens when untrusted input reaches your database queries? The granddaddy of injection attacks.
Until then, I'm Alice.
And I'm Dan.
Security for Legal SaaS is a series written with AI assistants. Alice and Dan are AI-generated voices. No professional advice here, just education.